Okay, if you need to pause the video real quick and draw this figure, okay, do that now. And when you're ready, restart. Okay, so looking at this circle, I have a radius of r. Okay, half my diameter is r. I am going to call the angle that this radius has gone through theta. Okay, if you're wondering what that is, theta is our Greek letter theta. You say it theta. And I am going to call the length of this arc on the outside S. So the interesting thing, if you look at the ratio of S over the diameter of the whole circle, so that would be 2 pi r, that is going to be the same ratio of theta, this angle measure, to the entire circle, which is 360 degrees, which we also said 360 degrees is equal to 2 pi radians. Okay, so if we cross multiply here, we are going to get 2 pi times S is equal to 2 pi theta times r. And if we divide by 2 pi on both sides to try to get S by itself, we're going to see these 2 pi's divide out and these 2 pi's divide out. And we're left with S, the arc length, is equal to theta times r. Okay, a couple important things here. Theta, when you use this formula, has to be in radians. Okay, so if you have theta in degrees, you have to convert it to radians, which we found out how to do above. And then you can only substitute in radian angle measures, for theta. Okay, so in this example, they give us the radius of a circle, they give us the arc length S, and they want to find the measure of a central angle in radians of theta. So we are going to use the formula S equals R times theta. I am going to put in 30 for S because it tells me right there that it's 30. I'm going to put in 5 for my radius, and I am going to put in, I do not know my theta. So I am going to divide by 5 on both sides, and you should see that theta is equal to 6 radians. So let's think about that real quick. So we have this circle with a radius of 5, and we want to think if the arc length is 30, right? How far around would it be? How many radians? So if you think about this, the circumference is going to be 2 pi times 5, right? So that is 10 pi. Pi I'm going to estimate as 3.14. So this is going to be about 31.4. So let's see, 30 is pretty close to 31.4. And think about it, 2 pi radians in this case, so is 10 pi, which is about 31.4. So if we are going, and this is about close to 6.28 times 5. So if I go 5, 6 times around, I'm going to get to about 30. Okay, and that's why my radian measure is almost an entire circle. Right? It would be 2 pi radians is the entire circle. In this case, 2 pi, well, in every case, 2 pi is about 6.28. So 6 radians would get us almost all the way around the circle. Our next one is a little trickier. And the trick, you're still using the same formula, but the trick here you need to make sure that your units are the same for your radius and your arc length. So you might have to do some conversion before that. So 1 meter is equal to 100 centimeters. Okay, so now both my radius and my arc length are in the same unit. So again, I'm using S equals R times theta. For S, I am putting in 750. For R, I am putting in 100. And I'm looking for my theta. So I'm going to divide by 100 on both sides to get theta by itself. And you should be able to see that theta is going to be equal to 7.5 radians. Okay, if you have any questions, please come to office hours to ask me.